Today we are going to be continuing with Unit E, Space Science. We are going to be starting section 1.2, Telescopes allow us to study space from Earth. The two key concepts for this section are light and other forms of radiation carry information about space, and astronomers use telescopes to collect information about space. If you recall, visible light is the only form of electromagnetic radiation that our eyes can detect. So electromagnetic radiation is energy that travels across distances at certain types of waves. We are going to be taking a look at the electromagnetic spectrum, and you will see that visible light is the only one that we can detect by the eyes, and other forms of electromagnetic radiation such as X-rays, radio waves, gamma rays, those are not visible to us. Electromagnetic radiation travels in all directions throughout space, and by studying the radiation that is emitted, we can learn about the size of objects, distance, and the movement of that object. Remember, visible light is the white light that is formed by a huge spectrum of different colors. So if you recall that when white light hits a prism, it gets refracted and you could see the whole spectrum. It consists of red, orange, yellow, green, blue, indigo, and violet, and that is what forms the rainbow. So in this spectrum, the colors of visible light appear in the order of their wavelength. Remember, wavelength is the distance between one wave peak and the next wave peak. You could see that red is the top color and this has the longest wavelength, whereas violet is the bottom color and this has the smallest wavelength. The electromagnetic spectrum also is arranged in order of wavelength. The one that has the longest wavelength are radio waves, and this is followed by microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. And gamma rays has the shortest wavelength. It is important to know in the electromagnetic spectrum that radio waves have the longest wavelength and gamma rays has the shortest wavelength. Astronomers use telescopes to collect information about space, and essentially what telescopes do is that they gather electromagnetic radiation. So many telescopes gather radiation with either a glass lens that could be convex and a reflecting lens, such as a mirror. So the larger the lens and reflecting surface, that's going to produce a brighter and more detailed image. Astronomers usually record images from their telescopes electronically so that they can use computers to analyze images. If you recall, we'd spoken about two types of telescopes earlier in this year. The first one was reflecting telescopes, and the second was refracting telescopes. Now, these two telescopes can be used to detect visible light. However, reflecting telescopes can also be built to gather infrared and ultraviolet radiation. If you take a look at page 17 in your textbook, you will see two diagrams, one for the reflecting telescope and the other one for the refracting telescope. The reflecting telescope operates in 3 steps. The first one is that the curved mirror will gather the light. The second step is that the image will be focused in front of the mirror. And the third step is that the second mirror will reflect the image to the recording equipment or to a lens called the eyepiece lens, and then we would be able to see the image. With a refracting telescope, there's no mirrors used here. Essentially, it's a long tube and you'll have an objective lens or a curved piece of glass at one end of this long tube. This lens will be used to collect light. In the second step, the image will be focused on the other end of the tube, and the third step will be that the eyepiece lens will be used to magnify the image. So remember, when you magnify an image, you're not increasing the amount of detail you're seeing. You're basically just enlarging the image. So the more you enlarge an image, the more blurred it's going to appear. Now, with visible light telescopes such as the reflecting or the refracting light telescopes, they tend to work better in far out areas, so not in the city. And this makes sense because in the city you have a lot of city lights, and this can really cause dim objects in the space to not appear as bright. So with working with visible light telescopes in rural areas, you're going to get better images. Another point about visible light telescopes is that they tend to work better when you build them on mountaintops. Now the reason for this is when you build visible light telescopes at higher altitudes, there's less air above the ground, and this would mean that there's going to be less interference by the Earth's atmosphere. If you ever recall on a starry night, you see the stars twinkling in the sky, that is due to air interference that's causing them to twinkle. So the higher up, the closer you get to the sky, the less interference you're going to get from the atmosphere and the more clear the image will be. If you take a look at page 18, you're going to see pictures of radio telescopes. Now, radio telescopes, you will see pictures of radio telescopes on page 18. Now, radio telescopes, they're used to detect radio waves that are being emitted by objects in space. Now, I'm sure we have all seen a radio telescope. It tends to have a huge curved metal surface called a dish, and this is used to gather radio waves, and it focuses them onto the antenna, and they're very large because remember, radio waves have very long wavelengths. So the radio telescope itself needs to be very large in order to be able to detect these long incoming radio waves. Now, unlike the visible light telescopes, radio telescopes, they're not affected by the Earth's atmosphere or by bad weather or cloudiness, and also they work very well at low altitudes. So you will tend to see a bunch of radio telescopes grouped together right on the ground. And the reason that they work better in groups is because, remember, radio waves have a long wavelength, so the more radio telescopes you're using to detect the radio waves emitted from one object, the clearer the image will be. Now the last page in this section, page 19, talks about the Hubble telescope. This Hubble telescope is operated from Earth, however it is located in space. Thus, the Earth's atmosphere does not interfere with the quality of the images, so you're going to receive the best quality of images possible. Now this telescope, along with other telescopes, orbit the Earth, and it gives us information about electromagnetic radiation, such as gamma and X-rays, and this is very important because gamma and X-rays tend to be blocked by the Earth's atmosphere. So in order to overcome this obstacle, they put the Hubble telescope in space in order to get the best quality images and information about these electromagnetic radiations.